Well, now we're doing Unit 6C, Part 2. And we'll start off with question 7. And for 7, we're told that the scores on a test are normally distributed with a mean of 70, a standard deviation of 5, and what is the percentile for an exam score of 61? So we've got a mean of 70, sigma equals 5, x equals 61. So there's our formula for the z-score, which is the number of standard deviations above or below the mean. So z, then the corresponding, when we find z, we get a value of negative 1.8. And so going to the table, the corresponding percentile for that will be 3.6%. Let's see, negative 1.8, and when we round that percentile to the nearest tenth, we get 3.6%. Yeah. So for number 8, we given that the volumes of soda in quart soda bottles are normally distributed with a mean of 32.3, a standard deviation of 1.2, and we want to know what percentage of bottles contain less than 32 ounces of soda, so x is 32. So we can find the z and the standard, or the number of standard deviations below the mean, and that's negative 0.25, meaning it's negative, meaning we're below the mean, and the corresponding percentile for that is 40.13%, and that's A, selection A. So now we'll go to 9, and for 9, we have a little teaching dilemma. The scores on a test are approximately normally distributed with a mean of 70 and a standard deviation of 9. And the teacher wants to give A's to the top 10%, so we've got 100% of the class minus 10% for A's, minus 25% for B's, minus 42% for C's, and that leaves us with 100% minus 77%, which corresponds to 23%. And that's our percentile. And now we'll go to the table and we'll look up the 23rd percentile below the mean, and we'll get a z-score of negative 0.75 from the table. Once we do that, now we can replace z with the appropriate value, and the mean value and the standard deviation value. We're going to solve for x. That's what we need to know. What score? What's the lowest? What is the bottom cutoff for the C grade? So when we solve for x with a little algebra, we get 65, so selection A. For number 10, we are given the area under the standard normal curve between 1 and 2 is equal to 0.1359. Scores on a particular aptitude test are normally distributed with a mean of 100. A standard mean of 100, a standard deviation of 10. And the question is, which of the following are equal to 13.59%? So that's a percentile. So here's what we're going to do. What we were given, that 1 and 2 are z-scores. So 1 above, 1 standard deviation above or below, 2 standard deviations above or below. And so if we're given a score of 80, that's 2 standard deviations below. So z is -2 and the percentile is 2.28. Please go to the table. If the score on the test is 90, then z would be -1, and the corresponding percentile is 15.87. And the difference between these two, the area between these two in terms of percentile, is 13.59. Now, if you look at score 110, that's 1 standard deviation above the mean and has a corresponding percentile of 84.13. If you look at the score 120, that's 2 standard deviations above the mean, and that has a percentile of 97.72, and the difference between these two is 13.9%. So our choice for an answer is D, because both B, the percentage of scores between 110 and 120, and the percentage of scores between 80 and 90 satisfy the criteria of having an area of 0.1359. Now for 11, the amount of coffee which and we have to state whether you would expect the data to be normally distributed, and the amount of coffee which a filling machine puts into 4-ounce jars, and I would have expected to be normally distributed. There'd be a little more, a little less. And state for 12, state whether the distribution appears to be roughly normal, and no, it's clearly skewed. It's not normal. So in both cases, our selections are B. And we're done.